To be able to zoom in our scene, we are going to use a pinch gesture recognizer. So let's begin by adding it as a property to our class, just like we did with our pan recognizer before. It will be a variable called pinch recognizer, initialized as a UI pinch gesture recognizer. We will of course set it up in our setup gesture recognizers method. But before we do so, I want to add the method that will handle the input so that we can directly assign it properly. To do so, I will scroll down to our extension where the other handler is implemented. Just like for the pan gesture, I will have to prefix Objective-C here and then call my new method pinch with a parameter sender of type UI pinch gesture recognizer. I can then go back to the setup gesture recognizers method, which I can then complete. I'll start by setting our pinch recognizer property to a UI pinch gesture recognizer with the target self, as well as the selector pinch, which we just defined. I can then use view.addGestureRecognizer to add the recognizer to our view so that we are able to use it. We now, of course, have to implement our pinch method in the extension to actually react to the gesture. Right at the top, I will add my God statement for the view again, since we will need it. So, God let view is view, and else we just return from the method. If we do get our view, I want to check if we had a valid pinch gesture with 2 fingers by checking if sender.number of touches is equal to 2, and only in this case I will implement the appropriate code for our zooming. I will begin by using another if statement with if sender.state is .changed, so if our user has actually pinched on the screen. We then have to think about what we need to do in order to zoom, and that is basically just scaling our game camera node, since, like I've mentioned earlier, this will for the user have the effect of a zoom by showing a smaller or greater part of our scene. It is important that we keep in mind that this is a camera, so in order to have a bigger image shown, we will need to scale our camera down to zoom out, and the other way around. Therefore, I will need to reverse the scale that we get from our recognizer, which I will do in a new constant called converted scale, which I can set to 1 divided by sender.scale, which will revert my scale. I can then use this scale to define a new scale for the camera node in a constant, which we'll just call new scale. And I'll set it to GameCamera.yScale. It doesn't really matter if I use X or Y here, since they will always be the same for our camera. And I can then multiply this with the converted scale constant. Now I can use the new scale by writing GameCamera.setScale and pass the new scale, which will actually apply the change to our camera node. This line will also set the X and Y scale of our camera. So it makes sense that it doesn't matter which we use for setting the new scale. So X or Y. This should actually scale my camera correctly, but I do want to add a few things that will make the zoom slightly better or more sophisticated. So first of all, I want to move my camera to the position where the user is pinching. Otherwise, it would just stay where it is, which might not be ideal or what the user expects. To achieve this, I will, above this if statement, define 2 more constants. One will be called location in view, which I will set to sender.locationInView, which will give us the position of the gesture in our view. And the second constant will be called location. And it will be set to convert point from view and pass the location in view constant as its argument. This defines the location before we pinch. I can then move into the if statement again, and after we set the scale, define another constant called location after scale, which I will set to convert point from view with the parameter location in view again, which will give me the position after the scaling process. I can now save the difference of these two positions, before and after the scaling, which I will do in a constant location delta set to a new CG point instance. For the x coordinate, I will say location.x, so the x value before scaling, minus location after scale.x. And for y, we'll say location.y minus location after scale.y, which will give me the offset of my position before and after our scaling process. I now want to create a new position for my game camera in a constant new position as a CG point. With the x coordinate game camera.position.x plus location delta.x, and for the y coordinate I will pass game camera.position.y plus location delta.y. This new position for the camera was now calculated depending on the location of my pinch gesture and the scaling that we've applied to the camera node. So all that's still missing is game camera.position and setting it to new position. Just like with our panning, I will reset the sender by writing sender.scale and setting it to 1.0, so that the next time we scale the camera, we will go off 1.0 as the current value, which will avoid strange or awkward jumps in scaling. Since we are now changing the scaling of our scene, I will have to update my camera constraints that avoid being able to pan or see beyond the map or the level. Since these constraints are set to a fixed frame, as soon as we change scales, they won't be right anymore. This can easily be fixed though by just calling GameCamera.setConstraints again with self for the scene, MapNode.frame for the rect, and nil for the node to just create new constraints every time we change the scaling of the camera. This should conclude our zoom mechanism, so we'll just run the app and take a look. Just like before, I'm still able to pan around in my scene. If I now pinch using 2 fingers, I can see a pretty decent looking zooming in and out effect. Well, what's maybe not perfect is that we can actually zoom in and out indefinitely. And if we zoom out far enough, we can actually see beyond the map again, which isn't what we want. If I zoom in on my scene and use the pen gesture, it also seems to be off. So the movement doesn't really match my gesture anymore, by being a lot faster than my gesture. So let's stop the app and fix this. I want to use some kind of limitation on my scaling in the pinch handler so that we are not able to indefinitely zoom in and out. I will begin by adding a new property to my game scene class, which I will add right below the pinch recognizer, and I will call it max scale. It will be of type ZGFloat, and I will just pass 0 for the initial value. I will then jump into the setup level method, where I've initialized my map node. And there I will set the actual value for max scale by setting it to mapNode.mapSize.height divided by frame.size.height. This should be a scale with which our map node should be completely shown, but nothing beyond it. I can then go back to the pinch method in the extension. And I now want to, before setting the new scale for the game camera, check if this still is a valid value we are allowing. So let's write if new scale is less than max scale. And I will also restrain it in the other direction by adding a logical and checking new scale is bigger than 0.5. So that we are unable to zoom in more than double the actual size. And only if these two are true, I will apply the new scale to my camera node. This should fix our zoom, but we still need to fix our pan handler. So let's take another look at the pan method right above, where we've implemented it. We just set the position of our game camera, going off the translation of our sender. This does not take into account any scaling though, which we can easily fix by just adding a multiplication by camera.yscale to my translation. Again, we could also use the X scale since they are both the same value for our camera node. I now get an error because I cannot multiply a CG point with CG float, which makes sense. I will fix this by creating a new file that should contain some little helpers and extensions for us. I will add the file to the template group where I want to add a new file as a Swift file with the name configuration. Inside of this file, I will add an extension for the type CG point, which will get some new methods. To fix the error we are now getting, I will just import the core graphics framework, which should then recognize the type CG point. I will begin with a static public func for multiplication. It will get two operands or parameters. One is left of type CG point and the other one is called right of type CG float. After the multiplication, I want to return a CG point. So inside of the method, I will just return a new CG point instance with X and Y values. I just want to multiply both the X and Y values for my past CG point with the CG float operand. So for the X value, I will say left.x times right, and for Y I will write left.y times right. As soon as I've added this method here, I can go back into my game scene, where my error for this multiplication should disappear, since the extension will now allow us to multiply the type CG point and CG float. And this simple multiplication will now make sure that even if our game camera scale changes, our pan will not be influenced. So let's run the app again and see if all this works. If it does, we should not be able to zoom in and out indefinitely, and our panning should be fixed and behave as expected. Okay, first of all, I can now only zoom in so far and not infinitely. If I then use my panning, it behaves as expected and not too fast or too slow. If I zoom out, I can see that the limit seems to work, but we do get a little black at the sides. And the problem is that our scene is wider than high, so we should probably switch something in the max scale property. I will stop the app, and for the next video, I have two small challenges for you. The first is that I want you to change the max scale property that we've defined here in a way that we will not see any black scene background when zooming out. And secondly, I want you to clean up the addition and subtraction of our CG points in the pinch method, since it's currently looking quite messy. You could use the extension for CG point in the configuration file to maybe add some new methods to the type that will allow us to directly add and subtract CG points from each other. Good luck!